All right, guys, today we're starting a new chapter over area. This first lesson is a pretty easy one. Some basic area formulas, most of which you probably already know, and the ones that might be new are pretty easy. They should all be in your flip books that you have from the last chapter, and of course, they'll be here on this video as well. So to start with this warm up, if we had a concave pentagon like the one shown and we had to find the area, I would suggest kind of dividing it up into three shapes, two triangles and a rectangle, finding the area of all of these separately, and then simply adding them up. In triangle number one, this of course would be 30. Just move this measurement up. And if this whole side is 40 and that's 16, now we have the base and the height of this triangle, which is all we need to find its area. Rectangle's pretty easy. All we need is 16 and 30. And then in triangle number 3, we got to come up with this side length. Of course, we would do that with Pythagorean theorem, which I'm not even going to show you, but that's what you would get. And find those areas separately, add them all up, and you should get 1,080. We'll do some more similar ones like that here in a second. Big reminder to get going, the base and the height of any polygon. I'm going to just write the symbol rather than the word, but they are always perpendicular. So what that amounts to is that a lot of times there are hidden right triangles in these pictures, and sometimes you have to do something with right triangles kind of on the side to come up with a necessary measurement. And again, we'll get a lot of practice with that as we go through these examples. All right, these four should be real familiar to you already. Not much to them. Remember, base and height of anything are perpendicular. So in a parallelogram, make sure that these two measurements make a right angle. In a triangle, make sure these two measurements make a right angle. A rectangle, it's kind of built in because the definition, remember, was that all the angles are right angles. So even though they have different variables, kind of the same idea. And then a square, of course, is just a side length squared. So let's try a couple easy examples. First one, find the area of this parallelogram. My cursor would cooperate. There we go. Something like this, it's as easy as base times height. And again, that's the key to it. So they just give us both of them. 9 times 14 is all you got to do. There you go, 126 square units. I'm not going to worry too much about the units, but obviously we are talking about area, so these are all some kind of units squared. All right, another parallelogram, that's what we're looking for. This distance right here we need to figure out before we can finish it. The base, of course, is 17. So if we write out our formula and start plugging in what we know, this is what I'm talking about. Before we can fill in this set of parentheses, we kind of have to go over somewhere to the side, and perhaps we can do it in our heads just to figure out the height. So again, one of the properties of parallelograms is that opposite sides are congruent. That's how I know that's 11. And if that's 60 and that's 90, of course we're looking at a 30, 60, 90 triangle. Go through your shortcuts. Tell you what, I'm going to kind of move over here in the middle and redraw this the best I can. Sorry, this isn't perfect. All right, so if the hypotenuse is 11, remember you just divide that in half to get the short leg, and then the long leg is the short leg times the square root of 3. And so that measurement just kind of gets pulled in over here. And now you're ready to go to your calculator and figure it out. And it doesn't say in the directions, but we'll round to the nearest tenth. So this is about, what, 161.9. And I'll go ahead and write it this time square meters because we're talking about area. That's all there is to it. All right, rectangles and triangles. Again, two formulas you're probably pretty familiar with. This one's similar to the warm-up question, where I would just find these areas separately and then add them up. So again, before we can find the area of this triangle, we're going to need to find this length. All right. So same story. If you kind of just work with the triangle, and again, I'm sorry, these pictures aren't great. How are we going to find that? Again, the answer is Pythagorean theorem, which again, I am not showing you the work, but that's what you'll come up with. And now you have enough to find the area of the whole shape. All right, so I would suggest doing something like this. Length times width is going to get you the rectangle on bottom, and 1/2 base times height is going to get the triangle on top, and of course we'll just add those together. So 14 times 26 for the rectangle. And remember, your length and base and height always have to be perpendicular. So in the triangle only, 10 and 24 are your base and your height. Doesn't matter which is which. All right, just go to your calculator and type it all in, and let's see what we get. So there's the rectangle. Sorry, cursor quit on me there. And that's it, 484 square centimeters would be your answer. All right, sometimes in triangles, and again, directions aren't real clear, but we're only finding the area of this gray triangle. The height, especially if the triangle, like the gray one, is obtuse, the height is actually shown out here. But again, the formula is pretty easy. Just 1/2 base times height. All right, now the base of the gray triangle only is 13, and the height of the gray triangle still needs to go all the way to the top. So even though it's out here, it would still be 7. Type that in your calculator and we'll see what we get. $45.5. Easy stuff, not much to it. All right, composite figures are simply when you kind of have to add or subtract areas together, and you've already seen at least one example of that on this one. Instead of obviously adding a triangle to a rectangle, if we're only finding the area of the gray part, we need to subtract this white triangle from it. So again, like I said, sorry, my cursor's not cooperating. If you kind of start with a general formula like the entire rectangle, and this time it would be minus that triangle on top, and then just fill in everything you need. So the rectangle's dimensions are 15 and 38. The base and the height of the triangle have to be perpendicular, and I don't see a right angle anywhere. And I guess it's just because this isn't labeled very clearly, but this is a rectangle, so all of these are right angles, making that distance a height. Whole thing's 15, this part is 8, so it'll be written kind of small there, but a little quick subtraction will get you 7, and then again, obviously this is 38. Same side as, or same distance as the side across from it. So we need a 7 and a 38 for the base and the height. And we just go type it all in. All right, what did I do? 15 minus 38 will get the whole rectangle. 1/2 times 7 times 38 is what we need to subtract from it. 437. Oh, there's my cursor. All right, and this shape, obviously you have a triangle here, a parallelogram in the middle, and another triangle. Sorry about my cursor. Over here. Now we could find all those separately and add them up, but since the top and bottom are parallel, this, besides being a composite figure, could also just be thought of as a trapezoid. And I'll skip ahead a slide. There's our formula for area of a trapezoid. You need both bases. Remember, those are the parallel sides. The height has to be perpendicular to it, just like this picture shows. And then just the number 1/2 in front of it. So let's solve this question by using that formula. Man, cursor is not cooperating. Okay, here we go. So 1/2 times the height times the sum of the bases. That's what we need. All right, so if the height is the perpendicular distance between the bases, it's going to be 12. Now one base is this entire thing, which is 8 plus 22, which is 30, plus 11 more is 41. Come on, cursor. And the other base is this one right here, and the parallelogram in the middle. Use your properties from last chapter. Opposite sides of a parallelogram are congruent. That's how I know that's 22. And now I'm ready. There you go, 378. All right, so even though you already saw this slide, we'll just talk about it real quick again. To find the area of a trapezoid, you need both bases. Those are the parallel sides. You need the height. That's the perpendicular distance between the bases. Wow. I apologize for all this craziness with the cursor. Okay, and then just the number 1/2, and that's it. All right, and then finally rhombus and kite. Even though these are different shapes, their area formulas are exactly the same, and all you need for these are both diagonals. Now, a couple things to remember. In a rhombus, okay, here we go. In a rhombus, because it's a parallelogram, remember both diagonals are bisecting each other. So remembering this property from the last chapter might help. In a kite, only one diagonal is being bisected. But again, once you know both diagonal lengths, just multiply them together and then times 1/2 for a rhombus or a kite. All right, this shape is obviously a trapezoid. So instead of writing the formula, I'm just going to say the variables, but write the numbers this time. 1/2 times the height times the sum of the bases. That's 10. 1/2 times 4 is 2, so 2 times 10 is 20. Sometimes they're pretty easy. You don't even need your calculator. This shape is a kite, so the formula is 1/2 of one diagonal, 9 plus 5 is where I'm getting 14, times the other one. And remember, that's where it's going to come in handy. Rather, the properties from last chapter are going to come in handy where you know both of those are 4. So 7 times 8, of course, is 56. All right. These problems are real similar. Why don't you pause the video for a second, try these real quick, and then see if you get the same thing I do. All right, for this one, 1/2 of the height times the sum of the bases. So I'm going to do a little bit of that in my head. That's going to be 6 times 21. Or 126. And this shape is a rhombus. Both diagonals in that shape are being bisected, remember, so one diagonal is 16. The other one is 6. That's going to end up being, what is that, 48? All right, sometimes you'll know the area and you just work backwards to find another part of the shape. And again, this shape, according to all those congruent marks, of course, is a rhombus. Get this crazy cursor under control again. All right, here we go. 1/2, one diagonal times the other. But you already know the area is 300. And you know that one diagonal is 15 plus 15. The other diagonal is x plus x. And so now you just solve for x. Easy stuff. X equals 10. All right, here's a similar problem. So again, why don't you pause the video for a second, try this one on your own, and make sure you get what I do. All right, this time it's a trapezoid. So there's my formula. I already know the area is 39. I know the height is 6. I know that one base is 9 and the other one is x. So I'll just do the algebra and solve for x. And there you go, x equals 4. All right, back to what I mentioned earlier. Sometimes what you have to do is something with right triangles kind of on the side, so to speak, before you can finish the formula. Again, those congruent marks tell you that this shape is a kite. And so what I need are the lengths of both diagonals. If I start filling in what I can in my formula, I know 15 plus 24, or 39, is going to be that horizontal diagonal. But the other diagonal, even though I know it's being bisected, I don't know what it is yet. But remember, one of the properties about kites is that diagonals are perpendicular. So in this triangle right here, if that's 24 and that's 25, and your cursor would cooperate, come on cursor, you can do Pythagorean theorem to figure this out. All right. Again, a couple times earlier in this video, I didn't show you all the work for that, but I'll go ahead and do it this time. 25 is your hypotenuse, 24 is one leg, and give this a name, obviously, like x. That's going to be your other one. So 25 squared, you'll end up subtracting 24 squared. And taking the square root of that, which is going to give us 7. And so that's what I mean. Sometimes you kind of have to go over to the side and do something. It's usually with right triangles to figure something out about your picture. So now we know that if this is 7, this is 7, meaning the entire diagonal is 14. All right, 1/2 times 39. Come on, cooperate with me. Here we go. 39 times 14 is 273. All right, the exact area of this trapezoid. Pretty much the same story. Write down your formula. Fill in what you can, and anything you're missing can probably be found with right triangle stuff. So this time, it looks like I don't know the height. I do know one base is 10 and the other one's 24. And if you draw a line right here, it might help you see the 45, 45, 90 triangle where you're going to do your work. All right. Technology will cooperate. There we go. All right, so hopefully you can understand where the 14 is coming from. And in a 45, 45, 90 triangle, the legs are the same. And that's how you end up figuring that out. So again, some of this can be done in your head. This is just going to be 7. This, of course, is going to be 34. So 7 times 34. It's 238. Last example, the only thing I did was change the 45 to a 43. And so again, it's just something with right triangles, but this time it's not a special right triangle, but instead just basic trig that's going to get there. So again, if you drop this down and make this your height, and you know this is 14, same formula, same problem as the last one where we don't know our height. But this time, instead of a 45, 45, 90 triangle shortcut, I need to use this triangle only, which I'll try to recreate for you down here. Where we know that's 14. We know that's 43 degrees, and we want to find the height. So you go through your roadmap from way back in January. Nothing's going to work till you get to basic trig, and you'll end up doing tangent of 43 equals opposite leg over adjacent leg. Multiply both sides by 14, and that'll give you your height. Uh-oh, what'd I do? Oh, I had 314. Sorry about that. There we go. That's a little better. So now we know that I'm just going to write 13.1 when I round it. But now we know this height, which is in our calculator, can basically end up, and I'll just put a star in this part. So here's a little calculator trick. You don't have to save it. You don't have to round it. Just leave it sitting there and realize that it just sort of goes right here. And so in your calculator, all you got to do is the 1/2 times, remember, second negative key will bring up the last answer you got. And the sum of the bases is 34. And there you go, 221. What'd I do? I hit enter twice. Sorry about that. I'm just looking at the first one. 221.9 when you round it. And so anytime you do have to round an answer, as I've told you before, don't do it early. Be sure you wait till the very end to round it, and you should be in good shape. All right, guys, that's pretty much it. Good luck with your assignment.